Alright, hopefully you can see this, but obviously the quality is crappy. I apologize as usual. But this is my first little replication attempt of Slider's wireless transfer coils, the pancake coils. It's actually very impressive how these pancake coils are able to transfer the energy like they do. And I've tried a couple different setups, but right here is just a little test rig using a 213055, and I've got the circuit set up per Slider's diagram, except I have a 1K base resistor, half watt, and a 100K pot on here, which really doesn't serve much purpose. But as it stands, I have it hooked up completely normal, nothing but the 1K resistor, and the pot is all the way down, and it's drawing about 160 170 milliamps at about 1.2 volts or so. There's a AA battery down here, and as that stands, it's pretty impressive. I get a very good field off here. It's very awesome considering that's only 1.5 volts. And I got two LEDs on here in parallel, and the coil is actually a much higher turn coil. It's very very dissimilar from using one of these smaller little pancake coils. Now, I did notice that will also work, of course, but the 3-volt LEDs do not light up as bright as on this higher turn coil. Now, that doesn't necessarily mean that more power is transferring. I'd actually like to think it's more like this higher turn coil is just at a higher, lighting the LEDs at a higher voltage. Meanwhile, this guy is giving off a lower voltage, but in the end, it's probably transferring more power. But anyway, to compare, I've got another guy right here. This is just another little jewel thief. I've had this for a while, but this is made just using Radio Shack magnet wire, the kind that comes out of the 3-pack. It's green and gold wire, I believe, 26 and 30 gauge, wound together, using up the whole spool. And that is basically just another blocking oscillator with a set resistance on there. If I cut that on, put the same coil on there, see, that does the same thing, but there's hardly any range. I also have a core in there, a ferrite core, which helps it out. See, there's no range. No range. The field itself that it puts off is so small, it's only going to light the LEDs if the coil is facing the right way. As opposed to this guy over here, they'll light up whichever way you face the coil, because the field is just engulfing the entire coil, and you can see the range is much greater. Okay, now that is impressive power transfer. The only problem is at 150 milliamps, you can't say it is the most efficient. However, per Slider's recommendation, to solve that problem, you use a high-speed switching diode coming off your positive. So rather than attach your the positive of your battery directly to the positive input of your coil, you run that through a 1N4148 or something, or diode similar. Now, that does bring the output down considerably, but you can see they're still lighting, two in parallel. Still got a little bit of range, still very impressive. But look at the draw, 20 milliamps. I don't know if you can see that, but it's 20 milliamps, 30 milliamps. That's bananas. That's bananas. And that's exactly what Slider said he was getting. He was getting about 17 milliamps. Now, he also is using about a 100 ohm resistor between the negative and emitter to just block some of that current, which I have not tried. But at 20 milliamps, that's, let's be honest, that's crazy. Okay, now another thing I wanted to notice, I know this this pot I have on here is way too high. It's useless. But let's go ahead and bypass this 1K resistor. I'm just going to short it out with some leads. So now, with that resistor shorted, we're getting a little bit more light. Now we're up to about 50 milliamps, 50-60 milliamps. So now we're just using the pot as a resistor. But at least I noticed that while that pot is too high, it still has a little bit of adjustability. If I replaced it with a smaller value pot, obviously it would be better. But I can turn it down. Let's do this. Let's give it a direct connection to the positive without the diode, and we're back to a ridiculous draw, about 400 milliamps. So just to show, the circuit all by itself without the right resistances is going to kill your transistor or your battery. The field is amazing, but we're drawing way too much current. So that resistor, we're just going to leave that there. 1K serves a purpose. That brings us down to 160, 150. Still very impressive lighting. If I had a 1-volt power adapter, then I would just plug that joint straight into the wall and just be totally happy with that. Screw efficiency. But the fact that this guy is going to work off of 20 milliamps, that's ridiculous. That's ridiculous. That's amazing, because you would be lucky to have a Joule Thief that will light up some LEDs brightly from 20 milliamps by itself. That's how you know you have a good Joule Thief. But the fact that it's able to get some induction at this range, at that input voltage, that is pretty awesome. So I just wanted to show that. We're talking about 30 milliamps here. That is amazing. And the coil here is the power cable that came from a cigarette adapter. So it's not as thick as your normal appliance power cord. It's a little bit smaller, but it's just basically got the 2 wires stuck together. And I used that. It's got exactly 21 turns. Very small inner diameter. You know, I wound it as small as I could starting off. And there you have it. So you got this guy right here, which is not a pancake, much more turns of wire. I can get this thing to get off good light at about 80 milliamps, and it still runs down to about 0.9, 0.8 volts, about 40-50 milliamps. Still gives off good light, but there's no range. There's no range, and I'm fairly sure that the amount of power, the amount of current that is actually passing between these two is nothing compared to what is passing between these two, especially if I were to have a very similar pancake coil as my receiver, as opposed to this higher turn coil. But you can see all day, there you go, 20 milliamps. That is amazing. That is very amazing. So now on to try higher voltages and running other loads. That's pretty much the next step. But thanks for watching, and appreciate Slider. Check out his video. I'll put I'm sure everyone's seen it by now, but put a couple links down there. But yeah, there you go. 2N3055 pancake coil, 1K resistor, high speed switching diode from the battery positive to the positive input of the Joule Thief. Awesome stuff. Thanks for watching.